Hi, it's Rida here. In today's video, we're going to talk about complex numbers and how to use them in different type of functions. But our main focus today is in quadratic equations, basically equations of degree 2 or degree number 2 or power 2. But basically, before we go to complex numbers, we have to talk about real numbers. As quick reminder, it's our main focus now. We're going to talk about fundamental theorem of algebra, which is that simple. If you got a function f, and this f is in degree n, function f degree n in real numbers, obviously. Basically, this function f can get fx equals 0 of degree n, except or can get n roots. Roots are solutions, basically n roots or n solutions. But now in quadratic equations, which is fx, quadratic is number 2. This is what we call the quadratic functions. Quadratic functions are written in this way: ix squared plus bx plus c. This is quadratic equations. If you got this equation fx equals 0 in the real numbers here, I'm still talking about reals, I'm not talking about complex numbers. In the real numbers in here, if it says equals 0, basically how to calculate the roots in here, accept this equation here, accept two roots, as we've spoken about fundamental theorem of algebra. If you got n roots, that means this equation here can get n roots. Degree n can get n roots, degree 2 can get 2 roots. Basically in here, what are our roots? We have to calculate delta. We call it delta, so to get our solution, our roots, which is going to be b squared minus 2 times a times c. And this delta can accept, we would get 3 solutions here, or 3 numbers at the end of when we calculate our delta. It could be our delta positive, or could be equal 0, or could be negative. In real numbers, in R, if delta is positive, we can get 2 roots. Basically, we still with our completely fine with our function here. Basically, in our fundamental theorem of algebra, which is we can refer fundamental theorem of algebra. It says we can get 2 solutions, x1 and x2. If delta equals 0, we can get 1 solution, which is the first solution equals the second one, because you have to get 2. Basically, you have to write in your answer 1 equals 2, and then we can get the same number. Basically, we still got 2 solutions which are similar. If delta equals 2, we still in our focus. If delta is minus, basically lower than 0 or minus, we won't get any solutions in here, in R. To keep it simple and easy for you, in complex number is going to be exactly the same, except one thing, which is in this case in here, if delta is minus, basically fewer than 0. In here, what we can get, basically in real numbers, we won't have any solutions, but in complex numbers, what we can get in here 2 complex solution, which is z1. Our solution gonna be our roots gonna be this way, z1 or z2. Z1 can write it this way here, let's say q p or q plus I p, and then this one here is gonna be basically conjugate, if you remember, conjugate of this number here, which is going to be p minus I q, or q minus ip. It's basically the same, z1 and z2, if delta is minus in here. We're going to give a couple of examples and then we will understand it properly. Remember, in R, if delta is positive, it remains the same. If delta equals 0, it's going to be 2 solutions which equals the same. If delta is negative, that means in R we won't have any solutions. No solutions here. It's a no in R. But in complex number, everything remains the same, except in here. What we're going to say, in here we got 2 complex numbers as solution, which is z1 and z2. z1 is basically a real number plus imaginary number, and z2 or z1 star, which is the conjugate number, which is the same real number but minus a same imaginary number. As simple as this. Then in here, to make it easy for you and to understand it properly, in quadratic equations, quadratic is any function is written this way here: ix squared plus bx plus c. Got two solutions. Basically, in a complex number, got two solutions. If delta is positive, got x1 completely different than x2. If delta equals 0, basically here you can get two real solutions or two real roots, and then here two real solutions or two real roots, and then here I can get two complex numbers, which is the first one is the conjugate of the second one, to make it simple for you. If delta is negative, basically we can get two complex numbers as a solution for this quadratic equations, which is z1 and z2, but the relation between both of them are conjugate z2 or is conjugate of the first complex number, which is z1. You can write it the same part of this function in here. Sorry, this symbol here, which is minus instead of plus. Now we're gonna go to what's up with just one example to make it easy and understandable for you. I got it written here. Basically, what we can get, solve this problem, which is fx equal 2x squared plus 2x squared plus 2x, sorry, I have just to take my mic, 2x squared plus 2x plus, I'm just 2 because I will get it written here, plus 13. Okay, in here, to solve this problem in here, what we have to say is fx, we got real number, everything is completely fine, belongs to R, and then we've got fx equals 0, fx equals 0, and then this is the function you've got. Basically in here it's equals 0. I'm just writing it here, that's simple. It's not the form or respond, it's just to understand how to do it and to make it simple for you. First thing what we have to do, as we said, we have to calculate our delta here to find our roots, delta, and to see if we need, if delta is positive, if delta equals 0, or if delta is negative. We have to calculate data. We got this, our a, b, and then c. It's b squared, which is 2 squared is 4, minus 4a times c, equals b squared is 4 minus basically here it's 4 times 26, equals in here 4 minus 24 in here, 8, 9, 10. 4 minus 104, which equals minus 100. This is our delta. In here, to keep it simple for you, delta equals minus 100. Here we go. We got it. Is it delta here positive? It's a no, because we got minus. If delta equals 0, definitely no. It's so obvious. But we've got delta is negative. If we are solving this function here in real in R, we would say straight away there is no solution for this function here in R. But we are solving, we try to solve or find the roots in complex numbers. Basically here we can get two solutions, which is z1 or x1, I would call the x1, equal minus b minus square root of delta divided by 2a, and x2 equals minus b plus square root of delta divided by 2a. I apologize about this right in here, yeah, because I'm slightly bit bending. Okay, from here what we can get, minus b, this is b, is minus 2 minus square root of delta divided by 2a. 2a is 2 times 2, which is 4. 2a, this is a, is 2. 2 times 2 is 4. And then here is similar. It's going to be minus 2 minus 2 plus minus square root of 100 divided by 2 times, sorry, 2a. 2 times 2 is 4 in here. And then here 2 times 2 is 4, 2. In here, in a real number, it's impossible. Why? You can't see it clearly in here, because there is no way we can calculate the square root of negative number in a real number. There is no way we can do that. This is what we said straight away. There is no solutions, no way. But in a complex number, we knew that minus is, we can refer it to I. Basically, what I mean with that, do you remember we've got minus 1 equals I square. This is in complex number, which is I. Basically here, just to explain it, we use z equals x plus y times I, or a plus b times I, a real number, imaginary number, times I, which is a square, equals minus 1. And this is in complex number. We've spoken about this in a previous video. And then what we can do in here, we can write minus 2 minus this minus in here. We can, it's like, transfer this number here into a positive number. How we can do that? Minus in here under the square root, we can refer it to a square times 100. Square root divided by 4, and is the same in here. Minus 2 minus square root of plus square root of 100 divided by 4. You can see now we transform this. We managed to transform this negative number minus 100 into a positive one, which is square I times 100. And then we can definitely now calculate square root of this number, which is that simple. Minus 2 minus square root of I square, which is I, square root of 10, which is 100, is 10, divided by 4. And in here, as you say, minus 2 plus square root of a square, which is and then 100, which is 10, divided by 4. And then from here we got our solution. X1, just to write it simple here, x1 equals this number here, which is minus 2 divided by 4, which is 1 divided by 2, minus I10 divided by 4. And then x2 equals minus 1 divided by 2 plus I 10 divided by 4 equals is the same, minus 1 divided by 2 minus I 10 divided by 2. We can say if we exclude a couple of common numbers, we're gonna be 5 divided by 2, and then here is gonna be minus 1 or half divided by 2. Is whatever you want to write it, they are all correct, plus I 5 divided by 2. This is our x1, or our first root, and this is our second root. Then this equation, remember this equation here, or this function in here, in complex numbers, you got accept 2 roots, which is the first one is the conjugate, or the second one is the conjugate of the first one. And this one of tricks, you can see if your calculation is completely correct. If you got in here a minus a times b and a plus I times b, is basically the same, apart of here the difference between plus and minus, because they are conjugate, then your calculation is correct. If you found that both of them, these complex numbers, are different, that means all your calculation, there's something going wrong. You have to look around if you made any mistakes. Again, in this function here, the root of this function in a real number doesn't accept any solutions because delta is negative. But in a complex numbers, we found 2 solutions, which is x1 and x2, or z1 and z2, whatever you want to call it, are complex numbers, real number plus imaginary number minus imaginary number, a real number plus imaginary number. But however, we've got the first solution, or the first root, is the conjugate of the second one, and this is how you can see if all your calculations is correct. If you don't find them, they are conjugates, that means there is something wrong and you have to look around it. This is all about the complex number in the quadratic functions in complex number, and we said here about the difference of founded solutions in complex number and real number. The only difference is just third case in here, when delta is negative, and then we can find our solutions. In the next video we're going to talk about the same complex number but in a cubic, basically here instead of square which is going to be times 3, basically power 3, x power 3. How many solutions can found? Obviously it's 3, but what type of solution can found and how to find them. And after that we go to number 4, which is power 4, etc, etc, and see how it goes. And then at the end of the 4th video we're going to give some examples or some questions and to solve these problems and how to do them in complex numbers. In the meantime, try to practice. The more you practice, the better it gets. Try to practice and see how it goes with your practice. If you need any help, drop me a text or leave me a comment. I'm more than happy to help. I will speak in the next video. Stay tuned. Speak soon.